Hello and welcome to the third part of Appendix B to the tutorial on writing your own operating system. Now, we already had the code to access the sectors of a hard drive. Then in part 1 of the Appendix B, we looked at the partition table at the beginning of the hard drive. This gave us an offset to the beginning of the partition, where we find the BIOS parameter block, and going from there, we could find the offset where the file allocation table starts, find where the data, the actual data starts, the names and types and all that stuff of the individual files. Yeah, and let's go through a few things again. So this offset we get from the partition table. This offset here is this reserved sector count here. This gives us the offset of the file allocation table. Then the size of this table multiplied with the number of copies of the file allocation table together gave us a pointer down here. You have multiple copies of the file allocation table. This tells you how many, and this tells you how large is every of these copies. So the product of these two gives you another offset down here. Yeah, and then down here you have the number of the root cluster. This is that was the root directory. C:\/ or whatever. So the top level directory on the disk, and so we iterated through the entries in there and printed the files in that directory. So that's what we did last time. But the point is we only loaded the first sector of this directory and the first sector of these files. So the question is, what is going on if the files are larger than one sector? I mean, a sector is only 512 bytes, so that's not much. So say this here is file 1. So the first sector we have read. By the way, the cluster number of the root directory multiplied with the count of sectors per cluster is actually the offset of the start here. So this number -2 multiplied with sectors per cluster, that is the offset to the first sector of that. Okay. So now we have read the first sector of that file, okay? Now, so if the file is larger than 512 bytes, then obviously you need to put it into different sectors, right? So you put different parts of the file in different sectors. And the first sector contains the first 512 bytes. Then the immediately following sector contains the next 512 bytes, the next sector after that, the next 512 bytes, the next sector after that, the next 512 bytes. Okay? But there's only this many sectors in a row belonging to the same file. Okay? If you have a very large file and your hard drive is fragmented, then the operating system will put parts of your file here, parts there, and so the idea here is that there's only a limited number of sectors in a row, which together form one cluster. So you read a full cluster, and if your file is larger than that, then you need to look into this file allocation table to find the next cluster. Okay, so I've drawn a little diagram here. So here's the root directory. It gave us the cluster of the first file, and we've found out the first sector of the file and read it. Okay, so in the next step we will read the consecutive sectors of that cluster, and when the cluster is finished and we still haven't reached the end of the file, then we have, so this is cluster number 5, okay? Here, 5. Okay? So then we just have to look in the file allocation table into position 5, and that will give us the cluster number of the next cluster. Okay? So I think that sounds simple enough, right? So let's just jump directly into the code. So here we have the file cluster. Here we load the first, so this is the first sector of the file. So in this loop, so inside this loop, we read the current sector. Plus sector offset. Okay, so we read the first sector, then print that. So we read the next sector of the file. Okay, so I don't think I'm explaining this very well right now. So so this is the first sector of the file, right? Oops. So this is the first sector of the file. And then we read the first 512 bytes. And after that, we decrease, we shouldn't make this unsigned. we decrease the size by 512, so we still have to read this many bytes. So after that, we increase the sector offset, so in the next iteration we will read the next sector. Okay. But so this would only allow us to read files that are larger than a cluster, that are smaller than a cluster. Okay, now we can read files which are larger than a sector but smaller than a cluster. Okay, so. So, so here we set the first sector of the first cluster, but we will put this in a loop. So the point here now is if we exceed the cluster, then we will break this loop. I think we should do this -1. So in this case, the current iteration has exceeded one cluster, so now we would need to get the next cluster. And how do we do that? So we need to set next file cluster. So that in the next iteration of this while loop, we then go to that next cluster, go to the first sector of that next cluster and start over there. Okay, so the FAT start partition offset. So that's a sector number. Yeah. So that's a sector number on the hard drive. Due to lack of time, I haven't prepared the code for this, so it might become a bit messy here. So the point is we need to find out the file allocation table will span multiple sectors also. So we need to find out which sector the current the entry for the current cluster is in. So this is just 4, but 512 divided on that should give us a number of entries per sector. Okay. Okay, so this is the sector number where we will find the entry for the next, where the next cluster starts. So here we don't go to the file sectors offset, but to FAT start. Plus FAT sector for current cluster. Read that into the buffer. Yeah, we could check. I think it would be better if we had another buffer. So that we would use this FAT buffer instead, and then always check: does the FAT buffer already contain the information that we are looking for? And then we would not have to read that again in that case. But I'll leave that to you. I think you can do that on your own. So I turn the FAT buffer into an array of integers, and from that I read this offset. Okay. I mean, of course, it would probably make sense to use a template here and use size offset template so that you could also use that for larger types later, but whatever. I'll leave it like that. So what I'm going to do now is I want to create a large file. Okay, so but I need to know how many of these, how large this file must be so that it spans multiple clusters. Okay, so we have 8 sectors per cluster. That means 4 kilobyte clusters. So I'm going to boot Tiny Core Linux again. So to create that file, I will boot Tiny Core Linux again. So I will mount the hard drive. Okay, and in here I will remove file 2. And now create a different file 2. So I'm gonna make file 2 have a lot of A's first. Okay. So you see we have a lot of A's now. And now I will put a certain string in the end. Okay, so now I'm gonna sync the hard drive because I have had really problems with TinyCore not saving the stuff to the disk in the end, so So, where were we? So if we have read a complete cluster and the size is still not 0, then we will read this. The part of the file allocation table. Yeah, I think that looks good. Yeah, let's see if that runs. Okay, this didn't work. So I found the mistake. Actually, there were several mistakes here. So here I set the buffer to the size that we got from the dir entry, and this is really a bad idea because this might be just somewhere in the RAM. No, we have to set it to the remaining size. Okay, so not to the complete file size of the files somewhere, you know. So this is basically this directory entry size modulus 512 after these iterations, okay? So that was one mistake here. Then another mistake was that there has been a break here. I don't know why I had it there. But that was clearly wrong because of that, of course we still only read the first cluster and everything after that was just skipped. Okay, then this test here had a larger or equal, must only be larger. What else? This test was between reading and printing the buffer. So because of that, the last sector of a cluster was skipped. Okay. Yeah, I think that was all the problems I had in here. Another thing is, here when I read the next cluster number, I take the bitwise AND with, the 32-bit integer that has all Fs, but the first one is 0, because, I don't think this caused any problems, but, the thing is that FAT32 actually only uses 28-bit bits for addressing the clusters. So, some people call it FAT28 because of that, but, this just makes sure that we don't interpret the bits that might be there and used for something else for anything other than for the address. Okay, so let's run this. Okay, here we have A's, 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 A's. And then here one final A and the end of file text. I'm wondering. Somehow this is printing it twice. Why is it printing it twice? But yeah, I don't care. So I think this should be enough so that you can now iterate through directories, you can iterate through files. And I think it's relatively clear how to continue from here. You would have a class file system which has a virtual method get directory traverser or something, and that returns you an instance. So you'll have a class file system with something like get directory traverser. And from that you derive something like the FAT file system, which overrides this with something that returns a new FAT directory traverser. And then you have an abstract class directory traverser, derived from that FAT directory traverser. And then you would have something like a file enumerator. So directory traverser would have something like get file enumerator. The FAT directory traverser would override that with a new FAT directory FAT file enumerator. So then that would have something like get name. That would override get name to read the name in the way that we did it here, and then maybe something like a file reader. with a method read that gets some buffer and how many bytes. And the FAT file enumerator would also have something like next. So the FAT, I mean, the base classes are all abstract, okay? And these derived classes get name and get reader and maybe something like so the directory traverser should also have something like get file writer. File writer with a method write with a buffer and a size. And derived from that FAT file writer. Yeah, and maybe something like flush or close, flush, close, and so on. Yeah, reader doesn't need to flush. I mean, closing doesn't even really make sense in this, yeah, so this would be a really object-oriented way of doing this. So, yeah, going from there, you could just work with the abstract classes in something like a directory, like a file manager, right? You would just ask the operating system to give you a pointer to an object of file system. Then you would ask that to get a directory traverser that gives you an object that points to the root directory. Yeah, you should also have something like directory traverser, like change directory. And maybe something like make directory and stuff like that. So, but the point is that that you have these abstract classes which give you an abstract interface to everything, and then you can just derive different subclasses from these for other file systems, you know. And then your file manager can just say, hey, operating system, give me a file system object. Then you get maybe a FAT file system object. You don't know, you don't care. So your file system object gives you a directory traverser, which points to the root directory in whatever manner there is. I mean, you could actually make a completely virtual file system with that. Yeah, but then you have this directory traverser, and with that you can traverse the tree. You know, you can go to a subdirectory, to a parent directory. By the way, in FAT there is actually a directory and an entry in the directory for dot, which is the pointer to the parent directory. So that gives you the cluster of the parent directory. Okay. Okay, so this FAT directory traverser would need something like the cluster number, which is a 32-bit integer. Okay. So you could use that object to go down in the tree, go up in the tree. And then you could ask the directory traverser, hey, now I want to know which files are in this directory. Then you could, so you ask it, give me a file enumerator. That gives you a file enumerator. You ask this enumerator, hey, what's your name? You can go to the next file. Yeah, and so if this isn't the file you were looking for, you just call the next method. Then this should jump to the next entry in the directory. And yeah, if you find the entry that you are looking for, the one with the correct name, then you say, hey, give me a reader for that, so that you don't have to think about things like clusters and everything. So yeah, then you have a file reader, and then you just ask that object, hey, give me some data, give me some data, give me some data. Okay. And this object, so the derived class FAT file reader would then have to deal with a sector count, with a number of sectors per cluster, and how large is the file and stuff. Actually, you should also have something like get size. This should also be a good idea. Yeah, so then you could really completely work your file management systems, your file management programs can work completely on the abstract interfaces, and yeah, your operating system just has to pass an instance of this FAT file system object to your file management system, and everything else is then completely on the file system's problem. Okay, you just talk to the abstract interfaces. You know, you say, hey, I want to go up in the directory, or I want to go into the subdirectory. I want to make a directory, whatever, and the concrete implementations in here have to deal with all the stuff like with the file names and everything, with the clusters and size of cluster and whatever. So yeah, that would be a good idea, I think. So then you could really work on a very abstract way with files, and don't have to worry in any way about how the file system handles this. So yeah, I think that's about it. I was thinking about, last time I said that I thought I read that the patent for the long file names was invalidated. I've looked that up, and I have found an article about that. But to my knowledge, the legal stuff isn't through yet, so I'm not sure if the patent is already invalidated or if it will be invalidated. And I don't know if there's any legal stuff. It's probably not finished yet. And if it's invalidated, Microsoft is surely going into revision or something. And I don't know if it is. I don't know if it is invalidated. If it's invalidated, it's probably being disputed, and then you still cannot. I still cannot teach you how to do this, and even if it's invalidated, then I don't know if this applies worldwide or only to the USA. Or I live in Germany, and I've read that the patent was upheld in Germany. So whatever, this is just too dangerous for me. I'm not doing it. So, but you will find documentation online, so it's not that hard. You'll be able to do that on your own. But yeah, so have fun with this. And hey, I was just going to say see you next time, but yeah, this is the last video. So I don't see you next time, except maybe. Yeah, maybe I'll do some more videos sometime in the future. I mean, there are topics like user space, USB devices. We've scratched on HTTP, but yeah, that's whatever. So virtual memory, we haven't touched virtual memory with paging and everything. So there's still a lot of topics that we could talk about, but the thing is that this room here won't be available to me starting tomorrow. So therefore, this is the last video for now. As I've said, I mean, I have a whiteboard at home, but yeah, maybe I will make some more videos in the future, but for now, this is it. Okay? So if you liked this video, hit like. Yeah, subscribing at this point is maybe not, but feel free to subscribe. I mean, I'm thinking about other things that I might make videos about, other than writing operating systems. You know, like, for example, writing parsers, so that you can make, for example, a programming language for yourself. But, yeah, as I've said, so from this room here, this is the last video, and yeah, maybe I'll, as I've said, maybe I'll do stuff on other topics, but so feel free to subscribe, but yeah, see you then, hopefully. Bye.